Hello again, problem solvers. We'll be going over the ice sheet for lesson 17, Inequalities. Make sure you have the ice sheet with you somehow, because I'm just going to talk about the problems, not write them down necessarily. Notice in your book that they go over AMGM. We're going to talk about that inequality, but also they talk about the Cauchy-Schwarz inequality, and we're going to skip that because it makes much more sense later in vector spaces. So if you take real analysis with me, we'll talk about that. But a far more important inequality for your future classes, especially advanced calculus, is the triangle inequality. And also, I think I've had a lot of students just struggle with basic inequalities before, rather than specific ones. So I've changed this lesson quite a bit since I first taught the class. So this, you'll still have AMGM on here, but we're going to also talk about some general inequality facts. So the very first one is about true or false. There's three facts here, and well, maybe facts. The first one, it says that if x is less than y, then xz is less than yz. You should know that's horribly false. Just take z to be negative. When it's negative, you should flip the inequality there. So that is false. Try any numbers. Try x and y positive and then z negative, and you'll see it. Okay, B says if x is less than 3 in absolute value, then this should be less than 3 as well. Okay, so this is kind of convoluted. What I find is I find students struggle with inequalities in the denominator. So let's try to figure this out. Let's take numbers kind of close to 3 and let's just plug in some numbers and see if this works. So I also want a number I can think about and do. So I was starting to put 2.9. I want to do this in my head. I don't have a calculator with me. So let's do x is 2.5. If it works, we'll try 3.5. Let's just play with it and try to convince ourselves if it's true or false. I don't see, obviously, right off the bat why this should work, but let's check it. So that's something less than 3. I guess I can't use 3.5, can I? But we could try negative 2.5. So that fits, and then if I go over here, I get 3.5 over 0.5. So dividing by 0.5 is dividing by a half, which means you double it. So you get 7, and that is not less than 3. Okay, so that's false. Then the last one says if x minus y is less than m, then that implies that x is less than y plus m. There are two ways to do this. In the notes, the PowerPoint, we go over the reverse triangle inequality, so we'll do that first, and then we'll also talk about maybe a simpler geometric way to think about it. So the reverse triangle inequality says that this should be less than or equal to this, or sorry, this is less than or equal to x minus y quantity, which is less than m. So if you have these two here, well, certainly if this is positive, so if x is greater than absolute value y, then that's just a positive thing. You move it over to the other side and you get what you need. What if absolute value x is less than absolute value y, then that expression over here would be negative absolute value x plus absolute value y, and that's supposed to be less than m. Well, if I have this, then let's just go ahead and put, I'm trying to show that absolute value x is less than y plus m. So let's go ahead and not make this harder than it is. I can play with this all day, but really what matters is what I just wrote up here. Don't make this harder than it is. If that's true, then that's certainly less than adding stuff, right? So you don't need to play with this. You just have it by, hey, you already have this inequality, add some more junk on the end. Okay, so that is a way to do it with inequalities, with the reverse triangle inequality, but also look at this. This is number line distance. So if x and y are within m of each other, so here's x, here's y, so their distance is this, and that's less than m. That means that x's magnitude, so if here's 0, this is x's magnitude, can't be more than y's magnitude plus m. Now here, y's magnitude plus m. That's clearly more. That's this case. If they're going in opposite directions, so say if x is over here, I might want this the other way around, but we'll do it here. If x is really negative and y is here, and then this is m, so x has the bigger magnitude, but x's magnitude can't be more than y's magnitude plus m. And you can check kind of the 4 cases, but you should believe that based on what you see on the number line. Okay, so that's number 1. The triangle inequality and the reverse triangle inequality are awesome facts. And we'll come back to them in just a minute. Okay, so 2 says x and y are positive numbers. Then look at this thing, and they kind of have x over 1 written kind of weird. X plus y over 2 squared. And then over 2. And let's show it's less than or equal to doing this. And it says find all cases of inequality. And the hint says keep doing algebraic manipulations that simplify until you get an inequality that's obviously true. Okay, so I can, as long as I do algebra to both sides of an inequality, it stays the same as long as you don't, as long as you're doing algebra moves and not inequality moves. So I'll explain what I mean by that after the end of this problem. So this inequality, I can rewrite this as, let's get rid of all these 2's to start. So if you think about this up here, inside here there's like a 4, and then there's a 2 on bottom. And so I want to get rid of as much of this as possible. So I'm going to try to multiply, I think, by 8 on the inside of both of these. Maybe even more than that, we'll see. Let's back up a step and make sure that we understand what we're looking at before I get too crazy. So this whole thing up top, the x squared over 1, that's really just x. I think we can agree with that. So let's simplify that a little bit. That's x, and then over here is x squared plus y squared over root 2 all over 2. This one over here is square root, and then it's x squared plus, well, let's leave it factor for now, x plus y quantity squared. But over 4, and then you got this 2 still inside the square root. Okay, so that was just simplifying. And now I want to get rid of, if you think about that root 4 is really a 2, and there's a root 2 on the bottom. So let's just multiply both sides by root 2 to start. Okay, so forget about the 2 on the bottom here. This side would be root 2x plus x squared plus y squared all over 2. And then this side, let's get rid of the root. That's a root 2, so let's get rid of those. Okay, so I have square root x squared and then x plus y quantity squared and a 4 inside. Okay, so let's do common denominator on this side. That's 4x squared over 4. And if I combine all that on that side, that's a 2 really on the bottom when you root it. 4x squared, this quantity squared, square root. And now I should be able to get rid of the 2's. So far, all I've done is legitimate equal algebra to both sides, multiply by 2. Haven't multiplied by any negatives, I haven't done anything weird. Okay, so finally, we can write this thing as 2x quantity squared, x plus y squared, root 2x, x squared plus y squared, but I still got a square root on this side. Okay, finally, I need to get rid of radicals. I lost my square root up here a long time ago, didn't I? Sorry, guys. Square root, square root, square root. Copy paste error. Okay, so now let's get rid of lots of radicals. So we're going to square root both sides. We're going to do that on a fresh sheet here. So the left side is easy. You get 2x quantity squared, x plus y quantity squared. Over here, that becomes 2x squared. The last term becomes x squared plus y squared. But what about that crazy middle term? You get 2 times root 2 times x times the square root. Okay, so I can cancel now lots of things, but first I should multiply some things out so that I can try to cancel. So this is 4x squared. I guess I didn't really need to make that way. 2x squared, x. So this crazy radical thing we'll leave alone, but let's cancel what we can. Y squareds cancel, x squareds cancel, 2x squareds become a 2x squared. So 2x squared plus 2xy. I guess actually those 2's cancel as well. Is that too? So x squared plus xy is less than or equal to root 2 x and then x squared plus y squared. And they all have an x as well, so one more cancellation, and I get x plus y. And we can put this all into one radical. And let's square both sides one more time. So I'll follow this out. And then 2x squared plus 2y squared. And then cancel these. So I have 2xy less than or equal to x squared plus y squared. Well, the simplest thing, I'm trying to get to something that is true. So something being positive makes sense. So if I move this over, I get the quantity x minus y quantity squared, which is a square, a perfect square. So that is always positive. And this is only equality if x equals y. So this is equality. Okay, there's an important subtle step. This is the final answer, so I got something obviously true, so it's okay. There's an important subtle step here. Because everything I did was a legal algebra move to both sides, I didn't do anything weird, this is enough of a proof. But if I did something like saying that if I did something like this, and I started with something false, and I multiplied both sides by 0, and I said 0 is less than or equal to 0, which is true, so therefore the original is true, that's crazy, right? That doesn't mean that 7 is less than or equal to 1. So you have to be careful that you're doing legal moves with positive numbers, or squaring both sides, or things like that. That line of thinking makes sense and is legal. Alright, so now we're going to go to number 3. That one was a bit of a doozy. Okay. Number 3 is a little crazy, but they give you a hint about A and GM. So the thing about A and GM is you always have to figure out what are the things that you're doing the arithmetic and geometric mean of. So if you think about this and you look at this, n is the product of the numbers 1 through n, right? In factorial, excuse me. So if that's in factorial is a product of 1 to n, then do A and GM on this. So let's just start there. So A and GM would say that if you take the geometric mean first, which is this thing here, 1 through n, that should be less than the arithmetic mean, which is add these and then divide by the number of terms. Well, that's the nth root of n factorial. And the top, remember that sum formula, and that's all over n. If you simplify this and cancel the n's, that's n plus 1 over 2. And then take the nth power of both sides, and you get the formula you were looking for, less than. Alright, the last problem asks you to generalize the triangle inequality. And we're about to bust out your favorite old trick, induction. So the triangle inequality says if you have two terms, this is less than or equal to the sum of these two terms. And now I'm going to do it in general terms. This is the base case, and that's by the triangle inequality. So if I want to go into my inductive hypothesis, and I want to say, suppose there exists K such that, I won't say K, excuse me guys, in the integers, or in the natural numbers really. If I go x1, x2 to xk, that's less than or equal to each term individually, absolute value. Okay. If I want to go one farther, well, I'm going to use the regular triangle inequality. So I have xk plus 1 is the new one. Think about these things as one number, and then you have the next one, k plus 1. That's the other number. The regular triangle inequality tells you that you can separate just those two. So here's the stuff without k plus 1, and here's the other one. That's the regular triangle inequality. And your inductive hypothesis says, hey, this stuff, I already know that breaks up. So this is less than or equal to x1 plus x2 plus xk, and then you have the new one from the last step. So that's it. Okay, so the point of that is that you can do the triangle inequality on several terms. You just do them individually and add up their absolute values. All right, so that's it for lesson 17. Ice sheet.